Flat earthers keep asking to see an example of gas pressure next to a vacuum without a container, yet I keep asking to see a container with a measurable pressure gradient, and so far, nothing. However, using what we've learned about gas in this video, I am going to argue that I can technically show flat earthers an example of gas pressure next to a vacuum without a barrier. Right here. Because, as we've already established, gas pressure is caused by molecules colliding with other objects, and a vacuum is an area where there is no matter. There's no stipulation about how much area there has to be for it to constitute a vacuum. If I take a syringe and I push it shut and then I cover the end of it, there is hardly any air inside there. If I pull the syringe back, then the air pressure is now dropping to pretty much zero. There are still a few molecules flying around inside, and those will create a very small amount of pressure, but in between those molecules is nothing. So the syringe as an entire system might not be a perfect vacuum, but inside we have areas of gas pressure right next to areas of perfect vacuum and no physical barrier separating them. There has to be nothing in between air molecules, because if I fill a syringe with air and then cover the end of it and try and squash it down, I can, because the air molecules still have space between them to move into. If there was no space to begin with, I wouldn't be able to compress the syringe. And space itself isn't a perfect vacuum. It's called a near-perfect vacuum. There are still air molecules whizzing around out there, they're just very few and far between. At sea level, the distance between air molecules is roughly 3.5 nanometers. Now, a nanometer is 1/1000th of a meter. Out in intergalactic space, the distance between molecules is more like 1 meter. So roughly 300 million times further apart. And an oxygen molecule is only 0.3 nanometers in size to begin with. To put this into perspective, if we were to take a bag of peas, with each one being 1 centimeter in size, and we say each one of those represents a molecule of air, at sea level each pea would be roughly 10 centimeters apart from every other pea. Out in intergalactic space though, each pea would end up being 30,000 kilometers away from each other. But the point is that the globe isn't some solid wall of atmosphere that we live in and then suddenly there's a void of nothing. In reality, the majority of air that surrounds us now is in fact a vacuum. It just happens to be littered with air molecules that allow us to breathe. As we see with the peas, each pea is a molecule of gas. Those molecules alone are what create gas pressure, and yet there is more areas of nothing between the peas than there are peas themselves. Which means every flat earther right now is surrounded by gas pressure that is directly next to a very, very small vacuum with no physical barrier in sight.